Good morning once again. Yesterday we studied about statistics on how to get the mean using an assumed mean. We did several examples, and as a recap, we're going to do one example. First method without simplifying, and the second method by simplifying, to see how best we can tackle these questions on statistics. The example, find the mean of the data below using an assumed mean. Any assumed mean. You're free to use, but in most cases, you'll be told the assumed mean to use. So the data, we have 11 to 15, 16 to 20, 21 to 25, 26 to 30. 11 to 15, the frequency is 3. 16 to 20, the frequency is 6. 21 to 25, frequency is 5. Then the last class, 26 to 30, the frequency is 1. As usual, we get the midpoint. How do we get the midpoint? We add the 2 and then divide by 2. So 11 plus 15 is 26. 26 divided by 2 is 13. 16 plus 20, 36. 36 divided by 2, 18. 21 plus 25, 46. 46 divided by 2 is 23. Then the last one is 26 plus 30, which is 56. 56 divided by 2 is 28. That gives us the midpoint of the classes. Between 11 to 15, the midpoint is 13. Between 16 to 20, the midpoint is 18. 21 to 25, the midpoint is 23. And the last class, 26 to 30, the midpoint is 28. We have the frequencies. So the first thing, we'll identify an assumed mean. Any assumed mean can work, but preferably choose from the numbers given and preferably one that's nearer the middle. So I chose 18 as my assumed mean. So I'll get the deviations, which is x minus the assumed mean. This is our x minus the assumed mean, which is 18. So our first deviation is 13 minus the assumed mean. 13 minus 18, we get negative 5. The second deviation is 18 minus 18, which is 0. The third deviation is 23 minus 18, which is 5. And the last deviation is 28 minus 18, which is 10. So these are the deviations from the assumed mean. So we multiply the deviations by the frequency. So negative 5 times 3, negative 15. 0 times 6 is 0. 5 times 5 is 25. Then 1 times 10 is 10. After that, we add the deviations. So those deviations are negative 15 plus 25 plus 10. That gives us 35 minus 15, which is 20. So to get the actual mean, we'll take the assumed mean. This is the assumed mean plus the deviations, which is 20 over the frequency. So 20 over the frequency. So that will give us 18. And this is 1 1/3. So 18 plus 1 1/3, that's 19, 1 over 3. So that makes it an easier process of getting the mean using an assumed mean. Looking at the third column, we have negative 5, 0, 5, 10. All these are divisible by 5. So we can make our process easier by dividing this by 5. So the same question, still the same classes, 11 to 15, 16, 20, 21 to 25, 26 to 30, with the same frequencies. Then the same midpoints. The deviations here were negative 5, 0, 5, and 10. Deviations from the assumed mean. So 13 minus 18, negative 5, 18 minus 18, 0, 23 minus 18, 5, 28 minus 18, 10. All these deviations are divisible by 3. By 5. Negative 5 is divisible by 5, 5 is divisible by 5, and 10 is divisible by 5. So when you divide the deviations by 5, negative 5 divided by 5 will get negative 1. 0 divided by 5 is 0. 5 divided by 5 is 1. 10 divided by 5 is 2. These are smaller numbers to work with than these ones. So it's easier to multiply a number by 1 than to multiply by 5. So we want to make our process easier. So we'll multiply now the frequency. This is our frequency times our t, what I'm calling t, the deviations divided by 5. So this will be 3 times negative 1. So I got negative 3. 6 times 0. That is I got 0. 5 times 1. That's I got 5. And the last one is 1 times 2. 2. Adding these again, very easy. -3 plus 5 plus 2 gives us 4. It's making our work easier. So our mean again is 18, then 4 divided by the frequency. And because this part we are divided by 5, then we must also multiply by 5, so that our answer remains the same, 19, 1/3. So the second method shows you how you can make work easier by dividing the deviations by a constant. So students, I want you to try this exercise. Try this exercise using an assumed of 34.5. Find the actual mean for the data. The data is 10 to 19, the frequency is 9. That is the number of seedlings against the height. Then 20 to 29, the frequency is 26. 30 to 39, the frequency is 39. And the last class, 40 to 49, the frequency is 26. Try to do the same using 34.5 as the assumed mean, using both methods to solve that. That is a recap, basically a recap of what we did yesterday. So today, we're going to learn on quartiles, deciles, percentiles for group data. Before we do group data, we would want to know what deciles are, what quartiles are, and what percentiles are. Now, a median divides a set of data into 2 equal parts with equal number of items. For example, if I have 2, 3, 4, 6, and 7. If I divide these are 2 and these are 2, then this will be the median. It will divide them into 2 equal parts. But quartiles divide a set of data into 4 equal parts. So the lower quartile, Q1, is known as, the lower quartile, Q1, is the median of the bottom half, while the upper quartile, popularly known as Q3, is the median of the upper half. Deciles divide a set of data into 10 equal parts. From the word deci means 10. Then percentiles, from the word percentage, divides a set of data into 100 equal parts. So deci into 10 equal parts, percentile into 100 equal parts, quartiles, there are 4 quarters in a hockey game, for example. So there are 4 quarters, 4 equal parts, and then the median divides it into 2 equal parts. For quartiles, deciles, and percentiles, the data must be arranged in order of size, mostly ascending order. So the data must be arranged. Before you get the quartiles, deciles, and percentiles, you need to arrange the data in ascending order. For example, determine the lower quartile and the upper quartile for the following set of numbers. So the set is 2, 4, 6, 6, 7, 7, 8, 9, 10, 11, and 12. If we count them, we'll see this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. There are 11 in total. So we divide them into 2. Already they are arranged in ascending order, so no need to rearrange them. They're already in ascending order. So if we divide, because they're 11, we can have the first 5 here, the lower 5, from 2 to 7. First 7, these are 5. Then we'll have, because they're 11, 1 will remain in the middle, which is 7. Then we'll have the upper 5. So these are the upper 5, and these are the lower 5. The middle one is what we call the median. 7, in this case, is alone. The 7 is what we call the median. Now, for the upper 5, we have 8, 9, 10, 11, and 12. The middle one amongst the upper 5 is 10. So our Q3, our upper quartile, Q3 is going to be 10. The lower 5, we have 2, 4, 6, 6, and 7. The middle number in the lower part is 6. And 6 is what we call our Q1, our lower quartile. That is for an odd number of items. The 11, so 5 will be on one side, 5 on the other side, and then we are going to have one median in between. Suppose they are not odd. The next one, for example, Find the upper and lower quartiles of the data below. Now look at them. This is 6, 13, 16, 17, 18, 20, 24, and 40. These are 1, 2, 3, 4, 5, 6, 7, and 8. An even number. An even number. So if you are to, already it's arranged in ascending order, so no worries about that. So we are going to remain with 4 below, that is the lower part, and 4, which is the upper part. Now there's no distinct number in between. If you look at this 4, there's no distinct number in between here, because there are 2 and there are 2, and we need to get the middle one. So the Q3, our upper quartile, we are going to add these 2, 20 plus 24, 20 plus 24, and because we are adding 2 numbers, we divide by 2 to get the mean of 20 and 24. So it's 20 plus 24 divided by 2, and that is our upper quartile. For our lower quartile, we have 4 numbers again, 6, 13, 16, and 17. We need a number in between here. So again, same drill, we are going to add 13 plus 16, 13 plus 16, and then divide by 2, and that's going to be our lower quartile, what we are calling the Q1. So these 2 examples illustrate clearly the difference between an even set of data and an odd set of data. For your exercise, you're going to try this out. Find for me the Q1 and Q3 of the data below, 11, 12, 14, 15, 16, 17, 17, 18, and 19. I reckon that it's, I think, odd. 1, 2, 3, 5, 6, 7, 8, 9. So there are 9. So we're going to have a distinct median. So before the next class, kindly try to do that. Quartiles, deciles, percentiles for group data. Now, for group data, we can use 2 methods. One is by classifying them and then getting the cumulative frequency and trying to estimate. Basically, it's an estimate of where the lower quartile is and where the upper quartile is. So our data is 11 to 20. These are marks scored by 100 candidates. The table below shows the distribution of marks scored by 100 candidates in an examination. So we have between 1 and 10%, there are 2 students. Between 11 and 20%, there are 5 students. Between 21 to 30%, there are 8 students. Between 31 to 40%, there are 19 students. Between 41 to 50%, there are 24 students, and so on. Total number of students, 100. So we need to estimate where the Q1 lies. Q1 is basically a quarter of the data. Where is a quarter of the data lying? So if we look at this, we do a table for the cumulative frequency. And remember to do the cumulative frequency. The first one is 2. Between 1 to 10, there are 2 students. Then we do 2 plus 5. That is how we get 7. Then 7 plus 8. That is how we get 15. 15 plus 19. That's how we get 34. 34 plus 24. So we get 58. 58 plus 18. 76. 76 plus 10. 86. 86 plus 6. 92. 92 plus 5. 97. 97 plus 3. 100. So the arrows indicate how to obtain the cumulative frequency. After that, now we want to classify these students. Between the cumulative frequency of 2 implies between 1% and 10%. There are 2 students. So let me call them number 1 and 2 from the bottom. So number 1 and 2 have between 1 and 10%. From 11% to 20%, there are 5 students. But from 1% to 20%, there are 7. That is the meaning of cumulative frequency. From 1% to 20%, there are 7. So it follows that from 1% to 30%, there are 15. From 1% to 40%, there are 34. That is the meaning of the cumulative frequency. Now back to classifying the students. So now, there are 2 students in this class, so that's number 1 and number 2 from the bottom. Then here there are 5. That makes it number 3, 4, 5, 6, and 7. The last student in that class is number 7. Then number 8 moves to the next class. And the next class has 8 students. So it will be number 8, 9, 10, 11, 12, 13, 14, and the last one is 15. These are 8 students, from 8 to 15. Then the next class, the next class is from number 16. So number 16 lies in the class 31 to 40. So we have number 16 all the way to number 34. The next class we have number 35. The last one is 34. We have number 35 all the way to number 58. And it follows the next class we have number 59 all the way to the last one, 76. Then the next one, 77, all the way to 86, and so on and so forth. And of course, we expect the last class to have number 98, 99, and 100, because there are 3 in that class. So to get the upper quartile is 3 quarters. There are 100 students. Total number of students is 100. So we need to know where student number 75 lies. 3 quarters of 100. Where is student number 75? If we look here, the last one here is 58, 59. Definitely 75 lies here, because the last one here is number 76. So we take the lower class limit of this class, 51, the lower class limit is 50.5. Then we look for his position. His position is number 75 minus 58. 75 minus the last one, that's his position. So 75 minus 58 over the total number of students in that class. There are 18. So 75 minus 58 divided by the number of students, which is 18, times the class width. Between 51 and 60, the class width is 10. So you just get the position. This is the position of that student. Then the number of students in that class, then times the class width, which is 10. That will give us 59.94 as the Q3, as the upper quartile, approximately to 4 significant figures. Then we need the lower quartile. That's a quarter of 100. A quarter of 100 is 25. So we want student number 25. Number 25, the last one here is 15. So 25 definitely lies here, is somewhere here. So we know the class. We first identify the class where number 25 lies. After that, we take the lower class limit, which is 30.5. 30.5, the lower class limit. Then his position. So his position is 25 minus 15. So 25 minus the last one is 15. 25 minus 15. Divide by the how many students in that class. That class has 19 students. So his position is 25 minus 15, which is number 10. Out of 19, there are 19 students. Then times the class width. And the class width is 10. Then you add to the lower class limit of that class. That will give us the lower class limit, the lower quartile of that data. It follows, if you want the 4th decile, deci means over 10. So 4 over 10 times 100, that's student number 40. Where does student number 40 lie? In this class. Student number 40. So again, we take the lower class limit, which is 40.5. Then we look for his position, number 40. Number 40 will be 40 minus 34. 40 minus 34, which is number 6. Here we have 40 minus 34. Over the number of students in that class, 41 to 50, there are 24 students. So over 24 times the class width, which is 10. And that gives us 43. And that is how we are going to calculate even percentiles and any quartiles that you need, any deciles you need. That is the process we're going to use. Second method of doing the same work is using a graph. And the graph, I've done a rough one, not very accurate, is called a cumulative frequency curve. In other words, an ogive. Cumulative frequency curve can be used to obtain quartiles, deciles, and percentiles. Example, calculate the upper quartile, lower quartile, 60th percentile from the data given below. So what we need is the data you're given is X and the frequency, only these two. So from the word cumulative frequency, it means we need the cumulative frequency. So we'll take 3 plus 9, 12, 12 plus 13, 25, 25 plus 15, 40, 40 plus 5, 50, 50 plus 5, 45 plus 5, 50. So that is the cumulative frequency. So on this side, the y-axis, we are going to have the cumulative frequency, which goes all the way to 50. So I've done a rough one, 10, 20, 30, 40, and 50. That is the cumulative frequency. Then on the x-axis, this is the x and this is the y, we are going to have the upper class limits. So we'll start with the upper class limit of 49, which is 49.5, then 59, 54.5, 59.5, 64.5, 69.5, and the last one is 74.5. After getting the upper class limit, you only obtain a graph using the upper class limit against the cumulative frequency. So 49.5 will plot against 3. So approximately that's where my 3 is. 54.5 will plot against 12. So 54.5 against 12, that's approximately where my 12 is. Then 59.5 against 25. So approximately that's my 25. 69.5 against 45, and so on. So we'll get an S-shaped curve. And that S-shaped curve is what we're calling the ogive. Now to get the upper quartile from the ogive, we need 3/4. In this case, they are 50. So 3/4 of 50 is 37.5. So we'll approximately draw a line at 37.5. The line is straight and parallel to the x-axis. Where it meets the curve, we draw a vertical line. This will give us the Q3. So approximate what this point is on the graph, and that will be our Q3. If you want our Q1, it's 1/4 of 50. There are 50 students. So 50, 1/4 of 50 is 12.5. So we go look for 12.5, draw a line parallel to the x-axis. Where it meets the curve, go down vertical, and then that will be a Q1. And then if you want the 60th percentile, 60% of 50, that is number 30. So we'll go to 30, draw a line where it meets the curve, go down. That will be our 60th percentile. So that is a second method of getting quartiles, deciles, and percentiles using an ogive.